please let me know. I am going to record the session so that I can send it out later. So let me go ahead and get started
Okay, perfect.
with 3.1. So what 3.1 talks about are these things called quadratic functions and models. And so back in chapter 1, we were solving equations that kind of looked like this: ax squared plus bx plus c equals 0. And we would use like the quadratic formula and that kind of stuff. And so here we have our quadratic function right there. And we can write it in something that we call vertex form. So I'm going to write that right here on my notes. Vertex form looks like this. And I'm going to kind of do this part right here. Okay, so here's my vertex form. It says y equals f of x. Remember, y and f of x are the same thing. Equals a, and then parentheses x minus h squared plus k. And they're telling us that the number a is not going to be equal to 0. And then we have something called the vertex formula. And so what we're going to be talking about here in 3.1, we're going to be talking about the graphs of these things. So here it says the graph is a parabola with a vertex at h and k, and then there's something called the vertical line x equals h as the axis. So what these graphs kind of look like, I'm going to zoom out just a little bit so I can kind of show you. When we start to look at these graphs, what they're going to look like is a graph that looks something like this, or let me see, or a graph that's going to look, let's see, that's, oops, well, let me see, let me move that back up a little bit, move the mouse over here because I don't need it just yet. And this is x and this is y, and our other graphs might look something like that. And so these graphs are always kind of look like a U. They're going to kind of be like that shape. And the graphs are either going to open up like the way it did in the first one I drew, or down like in the second one. And these points right here, either that bottom point or this top point, that's what we call the vertex. That point right there and that point right there. And then there's something called the vertical line x equals h. They call that the axis. What they're referring to is kind of the line that cuts the graph right in half.
Okay.
So we call this here the axis. A lot of times we call it the axis of symmetry, and it's this kind of line that's kind of cutting the graph directly in half. And then the other thing we're going to talk about is, in these problems, we're looking at the number a. And if the number a is positive, then the graph's going to open up. And if the number a is negative, then the graph's going to open down. And so when we write it like this, that just means this here means positive and this one here means negative. Because if a is bigger than 0, well, numbers that are bigger than 0 would be positive numbers. And if this one here says a is smaller than 0, well, numbers that are smaller than 0 would be negative numbers. And so what we're going to do here in our problems is we're going to do a little stare and compare. And I'm going to try to do that with this first part down here where it says match the equation in 1 with the description in 2. We're going to try to figure out how that's going to go. Okay, so I'm going to kind of zoom out, but then maybe zoom back in. I'm looking for the critical parts that I want to know. Okay, so the first thing is when we have our equation that looks like this, f of x equals a, x minus h squared plus k, our vertex here is the point h and k. So the first thing I want you to notice is right there, there's a negative, but right here it's positive. So whatever sign I have right here, we're always going to change it when we're going to write the vertex. So kind of like the way we did in the circles, we had like x minus 3 squared and y plus 2 squared, and we would have to say when we're going to find the sum of the circle, we got to change those signs. We're going to kind of do that here, but we're only going to be doing it with this part. This number here will go exactly there.
Okay.
So what I'm going to do for these problems here is like I'm going to look at this one here. I'm going to call this number 1. and I'm going to say, okay, can I find the vertex of that parabola? So the first thing I would notice is, look, that's a positive 4, so I'm going to change the sign to a negative 4. This number, though, will stay the same. So the vertex of that particular parabola is negative 4 and positive 2. And then the next thing I need to figure out is, how do I know if the graph's going to open up or down? The way we know whether it'll open up or down is we're going to look at the sign of the number A. Now, the number A is the number that's in front of my parentheses. So if I look here, the number in front of my parentheses, even though I don't quite see it, that number really is the number 1. And since it's positive, this graph's going to open up. So then what I'm going to do now is I'm going to say, okay, which one would number, if this graph right here, or this equation right here has a vertex of negative 4 and 2, and the graph opens up, that would be matched with C, because that one has a vertex of negative 4 and 2, and the graph's going to open up.
Okay.
And then I'm going to do that for each of these, each of like the next couple of problems. So if I look at, like say I call this one number 2, and I say, look, let me see if I can find my vertex. Remember, this one right here is going to change, negative 2. That one always stays the same, positive 4. The number in front of my parentheses here, even though I don't see it, is a 1, which tells me again that my graph opens up. So then I'm going to say, okay, number 2 has a vertex of negative 2 and 4, and that's going to open up. So this one would look like it would get matched with part A. Alrighty. So far, am I doing okay?
Yeah.
Yeah? Okay, just checking. So look, let's do the same thing for the next one here. So first thing I'm going to do, I'm going to circle that number. I know I'm going to change that sign, negative 4. This one stays the same, positive 2. And if I look at the number in front of my parentheses, it's negative. That tells me that this graph, yeah. So because it's a negative 1, because the number in front of the parentheses is a negative 1, as long as it's negative, that's telling me my graph's going to open down. So I'm going to say, look, negative 4, it would be D, right? There you go. You got it. And then by process of elimination, the last one should be B, because that's the only one we still got left, but we can double check. So it's going to go negative 2 and positive 4. And that one we said is going to open down as well, because we got that negative right there. And there we go. Yeah, that gets matched with B. So
yeah, that's
what
pretty easy.
Yeah, it's not really that tough. And one of the things I really wanted to mention is that when the notes that I have here, and it's the same thing like I'm doing on YouTube, but those videos, they correspond like directly to the homework problem. So when you guys go to like the homework for 3.1, you should have a question, like your first question should be almost identical to this one here. It's going to be like exactly the same. I mean, the numbers will change, but the process will be the same. So I'm trying to kind of show you guys the problems that you're going to see when you get to your homework. Okay.
Okay.
All right. So look, let me go ahead and scroll down over here, and we're going to take a look. We got a couple of problems, and they're all going to be very similar. And the idea here is we're going to find like 5 different parts. And the first one says, let's find the domain and the range. Okay, so if I'm going to find the domain, the first thing I want us to remember is that the domain refers to the x values. Okay, and what I mean by it refers to the x values is if I were to take a point anywhere along my x-axis, like say this one right here, and if I were to go up or maybe down, whatever, would I hit my graph? So we'd go like this and we'd say, yeah, you know, because I can see that this graph is kind of going out that way, and I can see that this graph is kind of going out that way. Yes, if we were to go up, we'd hit the graph, right? And if we were to take a point here in the middle, we could go down, we'd hit the graph. The idea is, could we pick a point anywhere along the x-axis? And as long as we either go up or down, we should hit the graph. And the idea is we should, because even if I were to pick a point, say all the way over here, and I go up, and I'm going to kind of do this real quick, we can see that that line is going up, but it's kind of going at an angle. So at some point, they should meet. And the idea is no matter how far to the right, no matter how far over here I go, or how far over here I go, if I go up, at some point I should be hitting my graph, because this graph goes up forever and ever, and it's kind of, you know, going to the outside as well. So When that happens, then we would say that the domain of our function would be, oh, come on, what's going on with my pen? It's freezing on. There we go. We would say that our domain, sorry, didn't mean to go that far, is going to be all real numbers. And the way we write all real numbers is from negative infinity to infinity. Because no matter where we were to go on our x-axis, negative infinity to infinity, we could pick a point, we could go up or down, and we hit our graph. Now, the second thing we're going to find is we're going to find the range. So when we're going to find the range now refers to the y value. Okay. So I want to think about my y-axis, and I want to think about going from the bottom all the way up. So if I was cruising along the y-axis right here, the first time that I can move, say, either to the left or the right, and I would actually hit my graph, looks like would be right here. It looks like this is the lowest point of the graph, right there at -4. And if we keep going up, we would always hit our graph if we went to the left over here. And then again, because I know my graph does this, at some point I would have to move to the right. But we would always hit our graph, but we would start hitting our graph from -4. So for our range, we would say, look, we're going to start from -4, and because we're going up and up and up forever, we would go all the way to infinity. And so that's how I would write my range, because again, my range refers to my y values. Okay. Alrighty. And then, so that's part A. So part B says we want to find the coordinates of the vertex. Okay, so we can do the vertex. Remember we said we're going to take that sign, we're going to change it. We're going to leave this one alone. So my vertex here is going to be -3 and -4. Okay. Part C says we're going to look for the equation of the axis. Remember, that's the line that cuts the graph directly in half. So my axis is always going to be x equals whatever that number is. And in this case, it's -3. It's always going to be the x value of my vertex. Okay. And then part D wants us to find the y-intercept. And the way we're going to find the y-intercept is we're going to come back to the original equation that we have, and everywhere we have the letter x, we are going to plug in the number 0. So I'm going to put 0 plus 3 squared minus 4. 0 plus 3 is still 3 squared minus 4. 3 squared is 9 minus 4, which is 5. So the y-intercept is a point. And the coordinates of that point, in our case, we plugged in the number 0, and we ended up with the number 5. And it's always, always, always going to be plugging in the number 0. We're always going to plug in 0 for our y-intercept. And then whatever answer we come up with will be that number right there. Okay. Then the last part E says, can we find the x-intercepts? And we should be able to find the x-intercepts simply by looking at the picture. So if I were to come back here and I were to look at my picture, I'd say, look, here's an x-intercept right there, and here's an x-intercept right here. So if I were to say, what are the coordinates of that point? We'd say the coordinates of that point would be 1, 0. And then what about the coordinates of this point? That one would be -5, 0. So my two x-intercepts would be -5, 0, and the -1. -1, 0. And all I really have to do is just look at my picture. And again, when you're doing your homework problems, they should all be very much like this, where you can just look at the picture to find those x-intercepts, okay? All right, so look, let me try another one very similar. I'm going to kind of scroll up here. And let's see. So Liz, I'm glad you're here too. At any point, Liz, as I'm going through this, if you got any questions, please let me know, okay? So look, we're going to do the same thing here. We're going to play the same game. We're going to find each of these things. So remember, the first part we're going to look for, y'all, is the domain. Oops, there we go. The domain. Oops, that's not what I wanted to do. There we go. The domain, and the domain is always going to be from negative infinity to infinity. It's always going to be like that, okay? This part here, y'all, is never going to change. The parts that will change would be something like the range. Now, again, remember, the range refers to the y value. And when I'm thinking about my y values, y'all, I'm always thinking about if I was coming from the bottom going up to the top. So let's see. No, I heard something in the chat. Okay, Liz, I see you said you're having trouble connecting. I'm glad you're here. I'm just kind of going over this problem right here. Okay, so for the range, y'all, I'm always going to start from the bottom going up to the top. So we would say, look, remember this function here, y'all, has that line and those arrows. That means that the graph is going down forever and ever and ever, right? So if I was coming up from the bottom, I would always be hitting my graph, no matter, because I could just keep going to the left, and I'm always going to hit my graph. And I would stop hitting my graph right about here. So my range would end, the highest that we could go would be 2. So we would say, look, if we're going to come from the bottom would be negative infinity, and we're going to stop at 2. That right there would be my range. Okay. All right, now let's do part B. Part B says, can we find the coordinates of the vertex? Yes, we can. So remember, our vertex here, y'all, we're always going to change the sign of that number, -3. We're going to leave this sign always the same. So my vertex is going to be at -3 and 2. Okay. Part C, we're looking for the equation of our axis, and it's always going to be x equals whatever this number happens to be. So in this case, it's x equals -3. Part D, I want to find the y-intercept. And the way we're going to find our y-intercept is we're going to come back to the original equation, and we're always going to plug in the number 0. So I'm going to come back over here. Let me clean up some of this mess. Okay, and let's see. We're going to plug in a 0 everywhere we have the letter x. So -2, 0 plus 3 squared plus 2. So this is -2. 0 plus 3 is still 3 squared plus 2. Let's see. -2. 3 squared is 9 plus 2. Let's see. -2 times 9, -18 plus 2 is a -16. So our y-intercept is going to have coordinates 0 and -16. So again, just to give you like a visual of what that means, if I were to keep coming down like this, and let's see, this is 1, 2, 3, 4, 5, 6, 7, 8. I would have to come all the way down to -16 before that graph would actually hit the y-axis. That's what it's telling me. Okay. And now for the last part, y'all, we're going to find the x-intercepts. Now, what the x-intercepts are where does the graph hit the x-axis, right? So we could say, look, if we know that this number here is -3, then that one there has to be -1 and 0, right? I'm sorry, -2 and 0. Oops, my bad. -2 and 0, and then this one here would have to be -4 and 0, just by looking at the graph, right? Because we're one space over. So my two x-intercepts would be -4, 0, and -2, 0. Okay. So usually the x-intercept's pretty easy to see because all you got to do is look at the picture. You can see exactly where it's crossing the x-axis, okay? All right, let me go ahead and keep scrolling here, y'all. Okay, we're going to do the same thing, kind of similar idea here, and see if we can figure out what are they asking me to find. So here's the next problem. It says, given the graph of y equals f of x, let's answer the following questions. And it says, What is the minimum value of f of x? Okay, so I want to think about the word, minimum. Minimum means the lowest. So when we're talking about the lowest, we're thinking about the y-axis, right? So right here, that number right there, I know I just kind of erased it, but that number right there is 3. So we would say this number here, the lowest is at 3, okay? And then the second part says, for what value is of x is f of x as small as possible? Well, small is the same thing as the minimum and the lowest. So what it's asking me for is, at this point, what is the value of x? So we would say the value of x here would be equal to -3. Okay. So again, I know when I'm reading through the problems, sometimes it doesn't look like that's exactly what they're asking me to find, but trying to break it down, that's really what it is they're asking me to do here. Okay. Now, to get to the third part, this one right here, it's saying how many real solutions are there to the equation f of x equals 1? So I'm going to clean up some of this mess right here, y'all. I'm going to come back here. F of x equals 1, this means the same thing as y equals 1. So right here, there's y equals 1. What I'm going to do is I'm going to draw a line. Right here, this is y equals 1. And what we're really asking ourselves here is, does this equation, or does that graph hit this line? And we would say, well, it doesn't look like it because that graph is going up and this was the lowest point. So it doesn't hit the graph. So when it says how many real solutions are there, we would say there's 0 solutions. There's 0 real solutions, right? Because it never hits. Okay. And then we're going to do the same exact thing, but when y equals 4. Okay. So I'm going to come back over here and I'm going to say, look, let me clean that mess up. And let me do the same thing, but at y equals 4. So this is 3, that's 4. And if we were to ask you, how many times does the graph hit that line? We would say 2. Okay. That's really what they're asking me to do in this particular problem. And so now the reason I want us to get into that is the next part of 3.1, where is it? Here we go. Talks about this thing called the discriminant. And I'm going to explain what the discriminant is in a second, okay? So, y'all remember when we did the quadratic formula? The quadratic formula looked a lot like this right here. Okay, the discriminant is this part right there, okay? And we're going to have a couple of case scenarios, okay? So this number on the inside, this b squared minus 4ac, is what we call, let's see if I can fix this a little bit. Here we go. And I'll zoom back in as we need to. It's called the discriminant. And that number, y'all, let me see if I can get this a little bit bigger. Here we go. So b squared minus 4ac, one case scenario we can have is it can be a positive number. Okay, so I'm going to put a little plus right here. When it's a positive number, we're going to have 2 X-intercepts. So this is one case. Okay. Second case we can have is b squared minus 4ac is equal to 0. When that happens, y'all, we're going to have 1 X-intercept. And then the last case we're going to have is b squared minus 4ac can be a negative number. So let me put a little minus right there so we know that's negative. And in this case, we're going to have no X-intercepts, okay? Now, the other thing I want to mention, I'm going to kind of zoom in a little bit so we can see this a little bit better, is that we know that when the number a is bigger than 0, our graph opens up. And let me use a different color. Oh, I don't know. Let's go with the pencil. And we know when a is less than 0, the graph is going to open down. Okay. So the first thing I'm going to do here, y'all, is I'm going to come and I'm going to look at problem number 41. And it says, for the given restrictions on A, B, and C, select the corresponding graph from the choices A through F. And it says, hint, use the discriminant. So we're going to be using sort of this idea right here. Okay, so look, let me take a look at 41. And I'm going to do this in pieces, y'all. The first thing I look at in 41 is that part right there, where it tells me A is less than 0. So if A is less than 0, remember what that means. It means that my graph is going to open down. So out of the graphs that I have here, A, B, C, D, E, and F, these are the ones that open down. So I know that my answer for 41 is going to have to be either D, E, or F. The second thing I'm going to look at is this part right here. And it says B squared minus 4AC equals 0. So that's what's happening right there. So not only is the graph going to open down, but we're only going to have one x-intercept. That means it's only going to hit the x-axis once. So when I look at my graphs for D, E, and F, because those are the ones that go down, which of those graphs hit the x-axis? And just to give you an idea, y'all, this here is my x-axis, right? Which one only hits the x-axis one time? D, E, F. E, there you go, you got it. You got it. So 41 is going to get matched with E, okay? So now look, this is what I'm going to do next. I'm going to get rid of that because I don't need it. And I'm going to put an X through there. I've already used that one. I'm not going to look at it anymore. Let's do the same thing for 43. So look, 43, I'm going to come back here. First thing I notice right there, A is less than 0. Hey, the graph's opening down. So now I know it's going to be either D or F. So let's see if we can figure out which one it is. The second thing I want to look at is this part right here. B squared minus 4AC is less than 0. That's this one. That means I'm not going to have any x-intercepts. Which of those graphs between D and F also goes down but never hits the x-axis? Anybody know?
D.
D. There you go. You got it. Boom. Okay. So now let's take a look at the next problem, 45. First I'm going to look at, y'all. Oh, check a look at this. A is greater than 0. My graph's going to open up. So we know it's either going to be A, B, or C. Same thing, we're going to look at this part right here. B squared minus 4AC is bigger than 0. That's this one right here. We're going to have two x-intercepts. So between A, B, and C, because those are the ones that go up, which ones hit the x-axis twice?
C.
There you go. You got it. So again, we've used that one already. We've used D. I don't want to look at it anymore. Let's go to 42. So let's see. Okay, first thing, A is greater than 0. I know it's opening up, so it's going to be either A or B. The discriminant, this part inside, is less than 0, which tells me that we don't have any x-intercepts. So that one should be A, because it opens up and it doesn't hit the x-axis. And then we can look at number 44. Okay, A is less than 0. It's opening down. It's going to have to be F, because that's the only one I haven't used. It opens down. Let's see. The discriminant is bigger than 0, which means that we have two x-intercepts. Yes, that is F. So by process of elimination, we've already used this one. We've already used that one. It looks like 46 has to be B, but let's double check. It's greater than 0, so it opens up. Yes, it's opening up. The discriminant is equal to 0, which tells me I have one x-intercept. So yeah, that's got to be B. Okay. So guys, one of the things on the YouTube video, I do explain this business right here for you guys so that you guys can do it. It's just not necessarily kind of written out in the notes. It kind of is, but you kind of have to go back all the way up here to the very, very, very top. Let me see if I can find it so I can show it to you right here. And so what this part right here is telling us, y'all. So look, this one was, it was less than 0. We said there was no x-intercepts. When it's equal to 0, there's only one x-intercept. So this would be 1. And when it's greater than 0, there's 2 of them. So I know it's not written exactly the same, but that's kind of what it is. They're telling me there. my job is to kind of hopefully make it seem a little bit easier instead of having to go back to that green box and trying to figure out what it is they're actually telling me to do there. Okay. So now, what we're going to do for these next couple of problems is we're going to find the equation of the graph, the equation of the parabola, just by looking at the picture. So the way we're going to do this, y'all, we're first going to write out the basic equation that looks like this. Okay. Then the next thing we're going to do is we're going to say, look, this is my h, and that's my k. So I'm going to come back over here and I'm going to say, look, f of x equals a, x minus h is the number 2 squared, and k is the number -1, so I'm going to put a -1 right there. Okay, so we're almost done. Our equation would look like this, but we need to find a number for a. So the way we're actually going to do that is we're going to come back over here and we're going to say, you know what? This is really an x number and that's a y number. And if it helps y'all, we can write this, instead of using f of x, we can write it using y, because y and f of x really mean the same thing. So what I'm going to do is everywhere I have the letter y, I'm going to put a 0, and everywhere I have an x, I'm going to put a 0. So I'm going to put a 0 equals a, x, we're plugging in a 0, minus 2 squared minus 1. And now the only letter that we don't have is the letter a, and we can find it. Oops. So let me put a 0 right here again. Equals, let's see, a 0 minus 2, -2 squared minus 1. Okay, so -2, when we square it, gives me a 4. So that's really a 4a minus 1. I want to take this -1 and I want to move it to that side. So when we do that, it becomes a +1 equals 4a. So to solve for a, y'all, we'll just divide both sides by the number 4. And we get a is 1/4. Okay. And so now what we're going to do is we're going to come back to this equation right here. And all we're going to do is we're going to rewrite it with the number a being 1/4. And we got it. And I want y'all to notice something. If I were to look at the original graph that we had, which is right here, right? Wouldn't we say that graph is opening up? And so the number a has to be a number that's positive, and it is, right? So when I'm doing this, y'all, when I come up with my number a, just because I'm looking at my picture, if I come up with a number that's positive, that tells me I'm probably on the right track, because that's the kind of number I'm supposed to get. So if I come up with a number that's negative, then that would tell me, hey, you know what, I'm doing something wrong, okay? So look, we're going to try to do the same thing for the next problem right here. I'm going to go about it the same exact way. I'm going to say, look, y equals a, x minus h squared plus k. Okay, so here's my h and here's my k. So we're going to do the same thing we did before. We're going to go x minus, our h is actually a -2 squared, and my k is a +3. So the first thing I'd probably do here, y'all, is say, look, minus and minus is going to make that plus. And then I would come back over here and I say, look, remember, that's really my x and that's really my y. So I'm going to put a -1 right there equals a. X is the number 0 plus 2 squared plus 3. And so let's see, 0 plus 2 is just 2 squared plus 3. 2 squared is 4, so that's a 4a plus 3. I'm now going to move this 3 over here by going -3 and -3. And so when I combine those numbers, that's going to give me a -4 is equal to 4a. So when we divide both sides by 4, we're going to come up with a is -1. So now that I know that a is -1, what I'm going to do is I'm going to come back to the original problem that we had, y'all, right here. And I'm going to rewrite it. I'm going to write it like this. Y equals -1, or just negative. x plus 2 squared plus 3. Again, this graph here, y'all, was opening downward. So that told me that my a should be a negative number, and it was, right? So that's really how I'm going to do. We got 2 more like this, or actually I think 3 more like this, but that's really how I'm going to do all of these problems. I'm going to kind of use the same process every single time, okay? So look, let me go to the next one here. Again, very similar to the one we just did. So let's see. Y equals a x minus h squared plus k, right? And again, this is my h and that's my k. So x minus 1 squared plus 4, okay? And then remember, y'all, this is my x and this is my y. So I'm going to put a 2 right there equals a, x we said it was 0, minus 1 squared plus 4. Let's see. 0 minus 1 is a negative 1 squared plus 4. Let's see, negative 1, when I square it, actually just gives me 1. So this is just a 1a plus 4. So we can subtract 4 on both sides. And we're going to come up with a is a negative 2. Again, I'm getting a good feeling about this as my graph is going down. So my number a should be negative. And so what I'm going to do is I'm going to come back to this part right here. And I'm just going to rewrite it with a negative 2. X minus 1 squared plus 1. All right. So let's take a look. Like I said, I think there's just a couple more here, y'all, just to make sure, again, that we're doing this the right way. So let's see. Oops. Let me get my parentheses. H squared plus k. All right, so here's my h, and there's my k. So again, first step, y'all, I'm going to write it like this. X minus h, negative 1 squared, and with a k, a minus 12. Again, the first thing I'll do here, y'all, minus and minus is going to make that into a plus, right? And then again, this is my x, and this is my y. So the y used to be, I'm going to put a 0. A. X is the number 1 plus 1 squared minus 12. Okay, so 0 equals a. 1 plus 1 is 2 squared minus 12. 2 squared is 4, so that's a 4a minus 12. We can add 12 to both sides and get 12 equals 4a. And so when we divide both sides by the number 4, I'm going to come up with a positive 3. Notice again, y'all, the graph is opening upward, right? So we know that our a is going to be a positive number. And so all I really need to do is come back to this equation right here and just fill in the a that we got, which was a 3. X plus 1 squared minus 12. All right. So again, the process, y'all, for these problems is usually pretty repetitive, okay? And let me see. I think I heard something going on in the chat. Maybe not. My bad. Maybe. No, I think it looks like we're still good. Okay, so guys, let me do the last problem here. And so this problem, y'all, at the end of the semester, y'all, I've been teaching for 24 years, and so I think I saw this problem first, like sometime back in 2006 or 7, but I always thought it was kind of a neat problem. And so this problem here talks about the human cannonball. And so this guy gets shot out of a cannon. And so it says, as the countdown begins, David Smith Jr., the bullet, dons his safety helmet, slides down the slender barrel of his cannon, positioning himself to become a human projectile. The crowd joins in the countdown, and the announcer asks the audience to cover their ears as protection from the noise of the blast. 3, 2, 1, fire. David Smith Jr., the bullet, blasts into air, flies an average distance of 160 feet, and a height of 60 to 70 feet and lands in his pre-positioned safety net. This is a death-defying feat guaranteed to send shivers down our spine. What we're going to do, y'all, we're going to figure out the equation that describes David Smith Jr. as he gets shot out of the cannon. So what I want you all to think about for a minute is, let me go like this. Okay. So suppose here is the cannon. He gets shot out, and then he lands in his safety net over here. Okay. So again, if you notice the shape of my parabola, y'all, and I'm going to kind of go over it in the blue, kind of like the way the ones in the picture were, or in our homework problems were, or the notes or whatever. Okay, so the first thing I would say is, hey, you know what? This graph is opening down. A should be a negative number. Okay, so that's the first thing I notice about this particular problem. Okay, let's see. It says he flies an average distance of 160 feet. So let's say that this number here is 0. This number here is going to be 160. And then it says he reaches a height of 60 to 70 feet. Let's go with the top number. Let's say let's give him the benefit of the doubt and say that he reached a height of 70 feet. So I want you to think about something for a minute, y'all. If this number here is 0 and that number there is 160, do y'all agree with me that right here that number would be 80 because it's right in the middle between 0 and 160? And so if I were to think about this right here as a point, it would be the point 80 and 160. And so we could say, you know what? We can come back to do what we were doing earlier today, a little while ago. And we could say, look, this is our H and that's our K. So we're going to go A, X minus 80 squared plus 160, and then we can say, look, you know what? We have another point on the graph. We actually got two other points. We have this point here and that point right there. And this point right here, y'all, would be the point 0 and 0. So I'm going to use that one. We could use this one too. This would be the point 160, 0. But I'm going to stick with this one because, you know, zeros are easy to plug in. Remember, that's my X and that's my Y. So let me zoom up a little bit. So I'm going to put a 0 equals A, 0 minus 80 squared plus 160. Oops, you know what? I put the wrong number here, y'all. My bad. Wouldn't this number here have been 70? Because that's the height there. I just saw that right now. My mistake, my mistake. Oops, oops, oops. Okay, and so now I need to solve for A. So if I'm going to solve for A, I'm going to say 0 equals A. 0 minus 80 is a negative 80 squared plus 70. And let's see, 0 equals negative 80. When I square it, y'all, is going to give me 6,400 with an A plus 70. Just like we did earlier, I'm going to subtract 70 on both sides. So I get a negative 70 equals a 6,400 with an A. And then we can divide both sides by 6,400. And the only thing I'm really going to do here, y'all, is cancel that 0 with that 0. So I'm going to say A equals negative 7 over 640. And I want to point something out, what we said earlier. We said that our graph was going down, so our number A was going to be negative. And so when I write out my equation, use a marker that's a little thicker, or make this one a little thicker. There we go. So we're going to say Y equals negative 7 over 640. And I'm coming back to this equation right here, y'all. And I'm going to go X minus 80 all squared plus 70. And there is the equation that describes this guy who gets shot out of a human cannon, right? Or out of a cannon, he's like a human cannonball. And so I was doing this last night because I have a class that meets on Tuesday and Thursday in Wesco. So I was doing this with them last night, and I want to see if I can show you guys the same thing I did with them. Here we go, right here. Okay, so let me show, I'm going to share my screen with you guys. So I'm going to stop sharing this part right here. And I am going to share a different screen with you guys. Here we go. And I'm going to show them, I'll show you guys something.
You ever wondered what actors and actresses do when they have to shit really fast for a movie?
Okay, here we go. So, yeah, I think you guys can see this now. So there's the guy, he's going to be shot out of the cannon. Boom. And there's the camera on his helmet. You can kind of see everything that's happening, right? Okay, so look, real quick, I want to point something out. Somebody brought this up in my class. Actually, let me go back to full screen. Somebody brought this up in my class last night, which was, let me see if I can find it. Right about here. Let's see. Oh, man, I went too far. Okay, come back. I'll come back again. Okay, here we go. Right there, that's the vertex, y'all, because that's when he's at his highest point, right? And so there he is getting shot out of the cannon, and I think they do it again. You can kind of see it. There we go. He's right here at that's his highest point, so that would be right. And so I wanted to show you guys that. And then every time I've done, I've always done this problem. People always ask, how does somebody decide, hey, you know what, I want to be a human cannonball? So I'm going to show you. The way you become a human cannonball is your dad is also a human cannonball. So this is that guy's dad. Just to give you a little background here, right here, y'all, this is the border wall, and he's being shot across the border. This is in California. So he is actually in Mexico right now. This is Tijuana. And when you cross the border in Southern California, you end up in San Diego. So he's being shot across the border from Tijuana, Mexico into San Diego, California.
You have your passport?
Yeah, I carried it over.
How was the jump?
Good. Piece of cake.
Was it what you expected?
Yeah, it's easy. It's all right.
By this time, did you find out what was going on? Why did you jump?
For money. I get paid.
So anyway, he gets shot across the border, and I don't know if you heard him or not, but they had asked him if he had his passport, and he said he always carries his passport when he does his jumps. So anyway, let me stop recording here, y'all.